anyone got a topic or a question or whatever, and I'll try and answer them.
Yes.
Okay, who's a yes? Aaron, what's your
Yeah.
question?
So in this last unit, 9.2,
Mhm.
basically determine if they're orthogonal or not.
Correct. You want to talk about that?
Yeah.
Okay, so suppose I have two vectors. I'll call them U and V. And the question is, are they orthogonal, yes or no? It's a very simple question, right? Are they orthogonal? Yes, they are or not. Now, if you take two vectors and you start at the same point, let's make this one negative just to be more interesting. The angle between them, if that angle is 90 degrees, then that means that the two vectors are orthogonal. So you could use the word, are the two vectors right angles? You could use that instead. And the test for it is very simple. If the dot product is 0, then they are orthogonal. Right? They make an angle of 90 degrees, what other words, right angled, right? There's three things that are really equivalent. Well, let's check them out. Oh, and to complete it, if the dot product is not 0, then they are not right angled. Well, in this case, 1, 1,3, dot product, 2, -4. So it's going to be 1 times 2 plus 3 times -4. 2 take away 12, that is -10. So my conclusion would be that U and V are not orthogonal.
So that's all it is just taking the dot product.
Yeah,
dot
and if the dot product is 0, you get it. That's pretty much it. Now, if you didn't realize that shortcut test, couldn't you find the angle between them using the formula that we...
The U times V over... oh, no, not that one.
That one, right? Couldn't you use that formula? You'd find the angle was 90 degrees, right? And wouldn't that mean that it's orthogonal, right? So that would just be a lot more work to do the same thing. The reason why that works is if the dot product is 0, won't this whole fraction be 0? And what angle has a cosine of 0? The angle 90 degrees has a cosine of 0. So that's why that test works.
Okay.
Okay. Connected to that, imagine I gave you a multiple choice question that looked like this. The dot product is greater than 0. That's all you're told. Dot product is greater than 0. Is the angle between them 0, bigger than 90, less than 90, and I guess greater than 180, which is a bit stupid, but I'm putting it in because I can't think anything else. So here are 4 choices. And all I'm telling you is that the dot product is greater than 0. Which of those is the correct answer for the angle between the two vectors?
Would that be greater than 90?
Mm-hmm. So what else is good if it's not that one?
You want to say the question again?
Yeah. What is the angle between the two vectors, U and V? Is that angle 0? Is it greater than 90? Is it less than 90? Or is it greater than 180? What is the angle between two vectors when the dot product is greater than 0, when it's positive?
That would have to be greater than 90, right?
No.
No.
No. So what else, if it's not that, what else could it be? So it's not that one.
I guess I'm confused then.
Okay, then let's tell you this. It was written, we wrote it down once, so just means you missed it. That's not a biggie. We'll remind you again. If the dot product is 0, we just talked about that one, that makes the angle 90 degrees. If the dot product is a positive number, the angle is acute. And if it is a negative number, the angle is obtuse. So that's something for you to memorize. If the dot product is 0, the angle is 90 degrees. If the dot product is a positive number, the angle between the vectors will be less than 90, right? Will be acute, it'll look like that. And if it's a negative number for the dot product, the angle between the vectors will be obtuse, right? Bigger than 90.
Okay, yeah, I had wrote this down, but I just completely forgot about it.
Right, so, well, I could have phrased it better as well, right? So the reason why that's kind of nice is, can you see in a multiple choice world, you either know it or you don't. And most multiple choice questions that I give, if you can't do them in 3 minutes, right, you're doing them wrong, right? Whatever it is you're doing is not the way to get the answer. So just pick C and move on. Can you see in that question, you either knew what it was or you move on, right? So, and if you don't know in a multiple choice, or at least hopefully you say, oh yeah, I wrote that down somewhere and you could go and find it. If you don't know the answer, don't you just pick C and move on anyway? Because, staring at a question for 20 minutes is not good. It just stresses you out and it's not like you're going to get the answer. And sometimes what happens is, an hour later, something comes into your head and you think, oh God, yeah, I remember now. And you go back to it and you change it to the right answer. And that's easy done. Okay, where are we off to now?
For the double and half angles, how do you tell if they move a quadrant, like during the problem?
So my audio didn't come through clear, Jason. So for the half angle problem, or
so for the double angle and the half angle problem,
okay, so
they can, they might be in a different problem than they started, or they might be in a different quadrant than they started in.
Correct.
How do you figure out if they moved quadrants?
Okay, that's well, there are 2 different versions of each of those questions. So let me start with the first one. If you were going to find, say, the cosine of 22.5 degrees, and the way you would do that is you'd find the cosine of 45 divided by 2. So this would be a half angle problem, right? Now, if you are being asked to find that one, it's dead easy to know what quadrant your answer is in. Your answer in this case is in the first quadrant because 22.5 is. If you're using a half angle formula to get 105 degrees, just for argument's sake, right? If you're using a half angle formula, don't you know what angle that guy is in? Isn't he in the second quadrant? Now, if you're using a double angle formula to do these kind of calculations, isn't the answer still, it's in the first or the second quadrant, right? The second version of that is a bit trickier. They don't always tell you what you want to know, right? You know the kind of question where they tell you the sine of x is √3/2, and they want you to find, say, the cosine of the half angle or the sine of the double angle, right? Those kind of guys there, right? That's a little bit trickier. So let's kind of show you how that would work out. They have to tell you a little bit more than just this. They always tell you something like, you ever seen it where they tell you that? Right? Or sometimes they just tell you a different version, X is in the third quadrant, right? They're going to tell you that, or they're going to tell you that, right? Or something that will allow you to tell what quadrant X is in. Now, I know what quadrant X is in, but I need to know what quadrant, say, a half X is in or 2X is in, right? So let's show you how that would work. Suppose I was wanting to find the cosine of half x, and I know x is in, say, the third quadrant. Well, the third quadrant is from 180 to 270, right? That's where x is. Then won't a half x, so that's from like 180 to 270, won't a half x be in the range 90 to what, 135? What quadrant is an angle that's between here and here? What quadrant is an angle that's, if it's in 90 to 135? Where would you find that guy?
Quadrant 2.
Quadrant 2. So if you're going to get a cosine, doesn't that mean the answer is negative something? Because second quadrant cosines are negative. Suppose I tell you that the angle is between 270 and 360. Right? Then won't the half of the angle be in this range? And that guy is also in the same quadrant, right? Suppose I tell you that the angle is in the range 90 to 180, then won't half the angle be in the range 45 to 90, and won't that make it in the first quadrant? Does that make sense? If you tell me where x is, if you tell me what quadrant x is in, can't I find the quadrant that half x is in? Now, if you're doing double angles, it's a little bit different. If they tell you the angle, then you know what you're doing, right? If they tell you that 2x is 200, you know it's in the third quadrant and so on, but they might not. So suppose I tell you that sine of x is this guy, and cosine x is, well, let's not even tell you anymore. Let's do a question straight from the top. Suppose I tell you that sine of x is equal to √3 upon 4, and I tell you that the cosine of x is negative. And the question is, find the exact value of sine of 2x. I know the sine of x is this guy, and I know the cosine of x is that guy. So I'm going to try and find out first what quadrant the sine of x is in, or what quadrant x is in. Right. The sine of x is positive. If you are positive and you're a sine, doesn't that make you in the first and second quadrants? Right. If the sine of x is a positive number, you have to be in the first or second quadrant because that's where the sine is positive. Where is the cosine negative? What quadrants does that happen? Well, the cosine is negative in the second quadrant. And where else is the cosine negative?
The third quadrant.
But what's the only quadrant where both things work? Do you see I now know that x is in the second quadrant? Since I am interested in finding the sine of 2x, I would rewrite it as 2 sine x cosine x. I would build a little baby right angle triangle, and I'd use this fella. The angle x, right? This is opposite, this is adjacent, this is hypotenuse. Sine x is √3 over 4. That's √3 over 4, opposite over hypotenuse. And the reason I build this triangle is I need to know what the cosine of x is. Well, I know this side and I know this side. Pythagoras, 16 take away 3 gives me that side. And then I can go and I can say, okay, the sine of 2x is 2 times the sine times the cosine. and you get an answer and it cancels down, but it's not quite correct. And the reason it's not quite correct, right, is what do we know about the cosine? Isn't the cosine negative? So won't this be negative, negative, and now we're finished? So that's how you tell if the answer is positive or negative for a double angle. You don't actually try and find out what quadrant 2x is in, because it's too difficult to do that, right? Because if you double it, there's 2 quadrants typically it could be in, right? And so you do it indirectly by finding out which quadrant x is in, and then you apply it to your formula, and your answer plus or minus comes out that way. So you don't directly find out where 2x is, you find it indirectly from the answer. Is that what you were looking for, Jason?
Yeah, I think so.
Okay, is there a specific example? Sometimes that helps, that I could do, and as I work through it, it might help you answer your question. Do you have one off the top of your head that comes to mind, even if the details aren't quite the same?
Not that I can think of, no.
Okay, well, you know, you can see me tomorrow or Monday if you come across a question. It's a good idea when you to write down a question that is, this is the kind of question I'm having trouble with. It gives me a little bit more information to deal with, you know, what I need to deal with. Anybody else got a question?
I did have another question.
Sure.
So, when are we supposed to use radians versus degrees? Like, are there some that we're supposed to always use radians or always use degrees, or some that it varies?
Right. When you see equation questions, for example, if they tell you that theta is in the range 0 to 2 pi, or if they tell you theta is in the range 0 to, let's say, 180 degrees, that tells you whether you should use radians, and that tells you whether you should use degrees, right? So if the information attached to the question looks like this, radians, if it looks like that, degrees. If they have a question where they don't mention radians or degrees, right? They just say, I don't know, solve, you know, 2 sine x equals 1, right? Typically in the WebAssign, they want you to do the answer in radians, right? So I won't even say that because the answer is going to be lots of them, right? If you, however, in a final exam did that answer and you did it as degrees, I would give you the points because I didn't tell you which, so aren't both equally correct. In WebAssign, if they don't tell you, it almost always means radians. I can't think of an exception to that. So if you don't see anything, assume that it's radians. If they tell you something, assume it's the, you know, assume it is whatever they tell you. Since I've got this one set up, let me just finish it off. I am looking for an angle whose y coordinate is a half. So how about that guy there, right? Would you agree he's got a y coordinate of a half? So one of the answers could be pi upon 6. And if I look for something else, it's over here. And the other answer I have is 5, 6 pi. When there is no restrictions, when the question just says solve this, that also means they want all the infinite answers that you could get. And isn't the formula going to be plus whatever the period is, k, plus whatever the period is, k. And hopefully you would say, the period of a single sine x is 2 pi. So plus 2 pi k plus 2 pi k. Now, it would also be totally correct if the question in the final exam had no mention of radians or degrees. that you decided instead to do things in degrees. So your answer would be 30 degrees and 150, which is what these guys are. And won't this be 360K? 360. Okay. Mathematically, aren't those two things exactly the same, right? They are equivalent to each other at least. Right. What would have happened if this question had been 2 times the sine of 2x equals 1? In other words, the sine of 2x equals a half. What would the period change to in this new question? We did this yesterday. What's the period of a sine of 2x? You use that number there, don't you? So the period of the sine of 2x
Pi?
would be pi, yeah. 2 pi divided by 2, it's pi. And wouldn't the other one be 360 divided by 2, 180? So it depends on whether it's degrees or radians. Okay, someone else got another question? I wonder if that, I don't know if that's a good sign. I'm hoping it's a good sign. But I don't know if it's a good sign because I can't see how puzzled your faces look.
Well, this one's kind of old.
I don't care. Go for it. What is it?
It's from 6.1. It was one of the homework questions, and I'm sure
Uh-huh.
we covered it in class, but just not
What?
clicking. So the specific numbers on my question were: cow is tethered by a 100-foot rope to the inside corner of an L-shaped.
Oh, I know that question. I'm going to
Yeah.
have to get the picture for that question because there's just too much to say in words, right?
Yeah.
Okay. So it was in 6.1 and it was the cow doing its thing, right? And I'll do a view on that. Do you know what number it was? At least I could use that.
On mine, I believe it's 19.
Oh, what? I've got the wrong section. What section is that in? 6.1?
Let me make sure.
Oh, it
Yes,
could be
one. Using
6.1.
an area of sectors.
Okay. I may have been in the wrong one. Okay. Just moving some windows around so I can see it. Right, it's 19. Okay. So let me zoom over and show you her picture, or a picture. And it's that guy with the cow, right? I'm going to draw all the key numbers because there's a lot of them in this picture. And then once I've done that, I'll come back. This is a puzzle question. So basically, this is like a one-off question, right? You get one shot to do it. And so there's not a lot of practice at it. So I'm just writing down A, B. There's a big long line here. Little cow. There we go. That's C. There's D. And finally E. And all they did is change the questions for different people, got different numbers. So the numbers I've got are A is 20, that B is 60, that the length of rope is 110, and that D is 70. And finally, E is 60. Okay. So what we're trying to do here is to find out the total amount of area that gets eaten by the cow. So it's attached to this 110, and we're going to look at what the shape would look like, right? What the area would look like of the shape of the piece of ground that the cow ends up eating. So this cow goes from here to here. So if I bend it from here to here, right, what you're going to get is you're going to get a big quarter of a circle. And that is going to be the maximum 110. Would you agree? On this side, if the cow was here, wouldn't it be 110? And then it eats in a big circle and it finishes up here at 110. Okay, so as I find these things, I'm going to try and keep note of them. So I guess we'll do it over here. I'll call this A. So A is a quarter of a circle. And the radius of that circle was 110. So that's that bit. So let's figure out what's going to happen down here, right? Well, when you get to 110, this piece here is 70, right? So isn't this piece here 40? See that little piece here, 40? Now, as you imagine the cow eating, what's going to happen is he's going to make a little quarter circle that looks like that. Agreed? And that I'm going to call B. And so B is 1/4. It's a quarter, that says. A circle. And the radius of that circle would be 40. And the reason it's 40 is the whole thing's 110. If that's 70, the bit that's left over is 40. So I'm trying to kind of imagine how this would work out. So got this guy, got this guy. Okay, let's make the 110 go up here. This piece from here to here is 60. Won't this piece here be 50 because the whole distance is 110? And what would that little 50 look like? Well, if you do that little 50, it's going to be a circle that goes like that. If you imagine that's a quarter of a circle. And C is a quarter of a circle and the radius is 50. And that little guy there is 20. So this bit is 50. I know it doesn't look to scale. This bit is 50. That part is 20. That makes this little bit 30. So I've got a quarter circle again, radius 50. And then you get to here. And so you've got a little 50, a little 50. And what you get is another little piece, a little quarter circle down here, which is going to be called D. And the reason that's 30 is this whole thing is the same size as that, 50 by 50. If this bit's 20, this little piece here that's going to bend in is going to be a 30. And so D is a quarter of a circle, radius 30. So if you can find all of them and add them all up, won't that be the final answer? So were you having problems figuring out the radius of these little quarter circles?
I think my issue was just like trying to figure out how everything worked in the drawing itself, I think. But please go over the actual solving the problem too, I guess. It's been a while.
Right. Were the radius of each of these four guys, are you comfortable why this one is 110, why this one here is only 40, but that one up there is 50, and then why this little baby one, why it's going to be a 30? Are you comfortable how I got those radii? Now, if you just go back and do, I think they have the feature, don't they? Try another. At least you get that in quite a few questions. It's open. If you want to practice, sometime later, go there, click on try another, and it'll change all the lengths, right? It'll change all these numbers, and it'll give you another shot at practicing it. And if you get it right, then yeah, okay, I've figured that out. Any other questions or topics or whatever? I mean, your time is very valuable. I don't want to just have you hanging about here because, you want to attend class and you don't want to be rude, but I don't want to keep you here if you've really not got anything specific yet. If you do, that's just as good. Question? Okay, so you've got attendance. I will see you maybe on Monday. I'm going to hang about because you might have homework questions, you want to talk to me, whatever. But Monday is open day. If you turn up, great, bring questions with you. If you don't, I'll assume that you're studying for your final. And all the information is on Canvas. It tells you what you need to do and what you can't do. Okay. So anybody got a homework question that wants to hang about? Otherwise, I'll see you later. Okay. Who wants to start the ball rolling then? Grace, I'm picking on you. Do you have a question, Grace?
Oh, I don't have a question. I was just going to see if anybody else had one.
That is a good reason to stay. None wrong with that. Has anybody got a question?
I don't have a question for the homework, but I just
Sure.
want to check. So Monday is gonna be another day, just like today, for just asking.
Yeah,
questions.
but much more open-ended. I don't. If you don't turn up on Monday, you're still given attendance.
Okay,
The
so
day if you didn't turn up, you wouldn't get it. But Monday, you don't need to. But I
Right.
will be here anyway.
okay, so we don't have to show up on Monday, but if we do, it's just ask questions like today.
Yeah, and if you only want to know the answer to one puzzle and you're happy, you just leave again, right? You don't need to turn up and stay for the entire hour if all you want to know is one particular thing and, okay, I've got it, I'm good, right? Because your time is valuable, right? I want you to make sure that, you know, you're doing stuff that's going to be of use to you. So you want to practice. It's better that you don't, you really just turn up and listen to me, if you,
All right.
unless
Thank
you
you.
want to. Okay, anybody else got a question? I guess you're all waiting till someone else asks a question. That's okay as long as someone asks a question.
So this is kind of just a general I don't have a
Sure,
specific.
that's great. That works too.
I think it was from the graphs from
Okay.
chapter or online test 5. I was just kind of confused about the horizontal shift and how you got that. If you could just go over
Right.
some
Let
of
me
that.
let me find a horizontal shift. Do you have a question number that I could use?
Yeah, just give me a second to pull it up.
Sure.
For test 5, I think question
Mm-hmm.
2 had the horizontal shift, and I messed that one up. So I don't really remember a ton about it. So if you could just, I don't know, give a general overview really quickly, I'd appreciate it.
Horizontal shift is how much the thing is shifted to the right or left. Right. So if you have I can write it down. So in the example that we've got here, we have 2 sine 5, 6 x take away pi over 6. And the horizontal shift is how much does the sine function get shifted to the right? And the answer was pi over 5. Now you had the answer negative pi over 5, which means I know that you were doing the right thing, but you didn't quite get it correct. And the reason for that is, let me show you a very simple situation. When this is negative, right, it's shifted to the right pi upon 3. And this is shifted to the left pi upon 3. And so we say that the horizontal shift, I'll call it HS for short, is positive pi upon 3. And in this situation, the horizontal shift is negative pi upon 3. So do you see that the signs here are not the same signs in the answer? You see there's a kind of oppositeness going on. And you know, if you do x minus 1, you're actually taking a shape and moving it to the right one. And so we call that a horizontal shift to +1. Now, the fact that you got this ugly number is good, because that's actually the hard part. Because what you have to do is you have to rewrite this as so many x minus a thing. So that has to be x, which means you have to pull out 5, 6. And if you pull out 5, 6, you end up with 1/5 pi. And that's the horizontal shift should have been 1/5 pi. So you must have figured that out. There's a little formula that you can use if you want to know how to do it. And the formula says, if you have an equation like so many x's minus a number, right, like we have here, the horizontal shift is positive b over a. So if you use that formula, you can do the horizontal shift. So if someone then said to you, 3 times the cosine of 5x minus pi upon 2, right? A would be 5, B would be pi upon 2. The horizontal shift here would be positive, right? Positive, pi upon 2 divided by 5, and that would be pi upon 10.
You aren't sharing your work.
I'm not.
I could do it.
I'll do it again.
No, sorry, I'm on my phone. I did it weird. My bad.
Okay, well, we're back to it. So here we go. So you can use that as a quick way of calculating horizontal shift. Right. Now, they've got another guy called phase. And phase is just that number. Horizontal shift is, you know, the corrected value. Horizontal shift would be the shape looked like that, and now it's moved over there, right? And phase is this number, and it uses the same pattern as before. If it's like that, it's positive, and if it's like that, it's negative. Do you see how the phase follows that opposite sign pattern? But the phase doesn't care about 5x, 2x, or a half x. But doesn't the horizontal shift? It does. It does care about it, right? It changes its value. But of course, isn't the phase shift and the horizontal shift the same thing when it's just an x? So that's a special case. But most of the time, the phase shift is just that number, right? And the horizontal shift is that number divided, in this case, by 2. Is that what you wanted to know?
I have a question.
Yes, Ali.
When it's a fraction for like the A
Is a
minus
horrible
B-
fraction kind of thing? Okay.
Oh,
What's your question?
I was just wondering. So, like, if like how you have the 2/3 x, that's when we have to pull it out.
Well, you can
both?
you can pull it out of both, right? I'm going to show you the shortcut one, right? So the shortcut one would be you take, call that A, call that B. So you take B and divide it by A. So you take pi upon 4 and you divide it by 2/3. And that becomes, I'll take it slowly, pi upon 4 divided by 2/3. And that becomes pi upon 4 times 3/2. And now you have 3 pi over 8, which means you can come over here and you can pull out the 2/3 x, and I've already figured out what's left because of the shortcut. Does that help you figure out how to rewrite it so that you can get the phase shift, in this case, of 3x pi?
Yeah, I was just a little confused because I saw we didn't pull out the 5 when it was 5.
Well, I could have, and if I did, it would have been the same answer that I wrote.
Okay, thank
So
you.
if you're only interested in what the phase shift is, couldn't you use this formula to just get the phase shift? Oh, by the way, I'm saying phase shift. I should be calling it the darn right name. Horizontal shift. I should be calling it its right name. What would the phase shift in this be? What would the phase shift in this question be?
Pi over 4.
Pi over 4. I mean, those two names have shift in them and they're confusing me.
Yeah,
Right.
I think that's what threw me off the first time when I was first doing this. It's just that I had them mixed up.
Yeah, easy done. Easy done. Are we good? So the horizontal shift is the shortcut. And the phase shift is you don't do anything, right? So horizontal shift, you have to do a whole load of calculations. Phase shift is just that number. Well, with a plus in front of it. Any more questions?
Are you gonna be uploading this lecture and Mondays so that we can like watch them later, or
Yeah.
okay?
Sometime about 7 or 8 tonight, because it takes me a while to download them and edit them and then upload them. I spend most of my time, well, I don't, I watch TV, but I have to wait a long time because it takes about half an hour to download it, and then it takes another half hour to upload it, and I spend about 20 minutes editing it. So it takes a lot of time because I have to do it with 5 classes. So that's why it takes like late evening for these to appear, but they will appear. And so if you
Okay, thank you.
if you don't turn up on Monday, you can watch the video for those who did turn up on Monday. Unless nobody turns up on Monday, in which case there's nothing to see. But hopefully some people will turn up. Okay. Any other questions?
I